Hello and welcome back. And in this video, we are going to discuss about the inline functions. So today's lecture is all about the inline functions in C++. Okay. So before going into the inline function details, let us discuss something about the macros. If you have studied the C programming, then you might be aware about the macro. A macro looks something like this: has define, and if you give like test code, and if it is defined something like test code, suppose x and y, then it returns like x plus y. Okay, so if we have written something like this, then if you write something like this test code, if you write like int k is equal to test code x plus y, which means 10, 12 and 10, suppose we are passing here. So if we do something like this, then when it will be expanded, okay, whenever you compile your code, all the macro definitions are first, they are, expanded. All the macros are expanded before your code could be compiled. So when it will be expanded, then how it will become? It will become something like this: int k is equal to x plus y, okay, which is test code xy, which means whatever you have passed as the arguments to this macro, that will be replaced with x plus y. So it will become something like 12 plus 10. Okay. Before the compilation, this will be converted into this line, and then the compilation will take place. So what does it mean? It means that whenever you use macro, in that case, whatever you have written for a particular macro, that macro will be expanded. Okay. This happens every time. Okay, and this is used to save some piece of code, some complex logic which you might need to you know uh, rewrite again and again. So to avoid that, we use the macros. Okay, the similar concept is for the inline functions. Why I am telling you similar? Because this is not same. There is a difference between similar and same. So what is the difference between a macro and an inline, that we are going to discuss right now? Okay, suppose we are writing a function int fun, okay, and you are writing like int a and int b, okay, then you are returning like return return a plus b. If you are doing something like this, and if you write this code, int k is equal to fun a plus b, sorry, 10 plus 10 and 12, then in that case what will happen? Do you think that this will be expanded here? No, this is not expanded here. In case of normal functions, normal function calls are placed on this stack. Which stack? You know that whenever a program is loaded into the process address space, then the four parts of that program are created. The first part is the code section, other part is the data section where all your static and global variables are placed. Then the next section is your stack, and then the other section is your heap. Okay, so these are the four sections which are created. So this stack section is basically responsible for putting the function calls, storing the return address of the function, storing the return values of that return values of some function, return values that you are going to return to some function. And to store those values, you need some register. I hope you know about the registers. Registers are nothing but the intermediate space where your return value from any function is stored. Suppose if you are returning a plus b from here, then whatever value you are returning, this will be stored in a register, and that register value will be returned here in this k. Okay, so from the register, the value which has been returned by this function, that will be copied from that register into this k variable. Okay, so this is how the function call happens. So when you are calling the function like this way, then in that case what happens, that first of all your function call goes to the stack. Okay, apart from putting the function call on this stack, all the arguments that are passed to this function, they are also placed on the stack. Okay. Apart from that, whatever value it is returning, to store the returning value, store that return value, we need a register. That register is also there, and all these things are maintained by the system when a function is getting called. So, suppose you are just doing this thing, return a plus b, which means you are performing summation, which is taking very less time compared to putting all these calls onto the stack. Okay, putting all these variables, the arguments into the stack, storing all these arguments into the stack, and then performing the operation, and after performing the operation, putting the resultant value into an intermediate register. So these are the different steps that are taking place, and these steps are taking much time compared to what the real function has to do. In reality, this function has to perform this thing only, a plus b. Okay, this is the only thing this it has to be performed. Okay, but still it has to go to the stack. It has to you know store the return values into some register. All those things it has to be done if we have written it as a normal function. Okay, so to avoid this kind of situation where the overhead of calling a function is much more than the actual operation performed by the function, the concept of inline functions was introduced. So if you have to make any function inline, what you need to do, you simply need to put like this, inline int fun this thing. Okay, so what does this mean? This means that if you will call this function now, like int k is equal to fun 10 and 12, okay, then in that case it will be, converted basically just like the conversion takes place for the macros. Okay, so whatever macros does, the same thing this inline function will start doing, which means whatever it is returning, all that thing will be analyzed by the compiler, and compiler knows that if it is returning some value, then wherever this function has been called at that point of time, it is returning at that point of location, it is returning the value, and it is saving the value somewhere in some other variable. Even if it is not saving the variable, just like if you only say like fun 10 12, then this function has been called at a particular instruction. So from wherever this instruction has been called to that address, this value will be returned. And if you are storing this into some variable like integer k, then in that case, the value that has been returned from this statement, that will be stored into k. Okay, so what does compiler do? In this case, what compiler will do, it will simply analyze this entire code, and it will find out that what my code is doing. It is doing like a plus b. It is performing the addition operation on these two variables that has been passed. So what it will do, it will again make a logical conclusion about this function, and then it will perform the operation, and it will give it to this in this form. So it will be expanded basically. Okay, so just like macro, it's not the exact expansion, right? It's the analysis by the compiler that how this code should be converted into in place code. Okay, so the inline function is nothing but the in place code to be inserted. Okay, okay, now the important topic. Okay, what is that important topic that we are going to discuss now? That is, like, is it like every time inline functions are expanded? Is it like every time you call the inline function and it gets expanded? The answer is no. It depends on the compiler optimization settings. Okay, so what is that? Let me share you the notes that I will share with you. Okay, so let me open those notes so that I can explain you better here. So it's here, and you can see this is the uh, you know function overloading inline functions. Yes, this is the one. So here if you see this thing, about the inline functions, then here I have mentioned like about the optimization of the C++ compilers. Okay, so based on the optimization setting, it will be expanded or not, it will not be expanded. So there are two cases. Let us read this line. If your compiler is optimized for speed, which means that if speed is important for your application and your compiler has been set in that manner that it will take care of the speed, it will take care like the speed should not be diminished for your application, then no matter how big your code inside the function is, it will be expanded. Okay. If your code is optimized for speed, you can see that this thing we have done for the speed only. We have make it inline. You know that all these function calls, they will not be placed on the stack, and all the registers, you don't have to worry about them. It will simply return here. Okay, so this will be something like this. Okay, so if your compiler has been optimized in such a manner that it will take care of the speed, it will take care like your application speed should not be compromised, then in that case this is certainly going to be expanded here. Okay, so if you see here, if your compiler is optimized for speed, then no matter how big your code inside the function is, it will be expanded. But if your compiler is optimized for space, which means that you want that your size of the exe should not be big enough. Okay, in that case what will happen, the function call will not be replaced. Okay, which means it will not be expanded. Replaced mean expanded. This will not be expanded here, because every time it will be expanded, and if the function is big, then in that case all that code will be expanded here every place wherever it has been called. And if it will be expanded at every place, then the resultant exe that you will create, that will have a bigger size. So if your if your compiler has been optimized to use the space in an efficient manner, you want that unnecessary your exe files, your binary files should not be bigger. In that case, what it will do? Will it expand it? No, it will not expand it, because expanding it will create a bigger size of the exe. It will generate a bigger code, and hence a bigger size of the exe will be there. So that is why the inline function expansion is not necessarily happening every time. Okay, so you can say that inline is just a keyword. It's not a command. It's just a request to compiler which could be denied. Okay, so you keep noted this line. This is very important. Inline is just a keyword, it's not a command. Command means whatever has been told to you that you need to do. Just like in case of macros, whatever has been told, like wherever it has been called, it has to be expanded. But in case of inline, it's not necessarily possible every time that it will expand itself, because it's only a request to the compiler, and compiler will check for uh, what kind of parameters I have been optimized. Am I optimized for the speed, or am I is someone optimized, if this compiler optimized me for the space. So based on those decisions, whatever it has been optimized, based on those decisions, these inline functions will be expanded. So that is why it's not a command, it's just a request, and request can be denied. Okay, so this was all about this inline functions today, and in the next video we will take care of few of the important questions that we have studied in against those topics, basically, which we have studied in the previous lectures, like about the operator overloading, like about the function overloading, and the references, all those things that we have studied in the past lectures. All those things we are just going to revise in the coming video, and after that, in the next video, we will start the classes. We will study about the classes. Okay, so I hope you might have enjoyed this lecture. I will share this lecture that I have shown you here, that I will share with you very soon. So keep watching this space and be with me, and you will be able to understand the C++ language at a very good and a moderate level. Okay, so thanks a lot, and we'll meet again us in this in the next lecture. So till then, have a nice day, and bye bye.